Alright, let's have a look at equations of lines. So a line on the xy axis, you can think of a line as an infinite collection of points that are extending in each direction, and all of these points satisfy a particular equation that describes the relationship between the x-coordinate of each of those points and its corresponding y-coordinate. So the equation of a line can be written in three forms, and just write down those forms for you. So we've got, first of all, you'll remember this one, slope-intercept form. And that's the one that we write down as y equals mx plus b, where m is the slope and b is the y-intercept. The next form, ax plus by equals c, is known as standard form. And lastly, we've got something known as point-slope form. And point-slope form, again, we can see the slope there, the m, and we can see a particular point on the line x1, y1. Some students ask, well, what about this x and this y? This x and this y is representing the coordinates of any other point on the line. The x1 and the y1 is a particular known point on the line. The slope, otherwise known as the gradient, is the ratio between the vertical displacement and the horizontal displacement. We know this as rise over run. You can also think of this as delta y over delta x. This delta triangular symbol means the change in. And of course we know that that's going to be the difference between the two y-coordinates on the points that you're examining the slope between over the difference between the x-coordinates. And of course it's very important that you maintain the order. If we have done the y-coordinate of the second point minus the y-coordinate of the first point, then in the denominator you must maintain that order as you take the difference between the x-coordinates. It must be second point minus first point. And one more thing about standard form. Ideally, we would like a, b, and c to be integers. And ideally, a would be a positive integer. Now then, I've written this word co-prime. Co-prime integers are integers that do not have a common factor greater than 1. So for example, if I had standard form 2x plus 4y is equal to 12, 2, 4, and 12, these coefficients a, b, and c, they're not co-prime because they all have a factor bigger than 1, namely 2. And so in order to put this into standard form, we should divide the equation through by that common factor. We'd end up with 1x plus 2y is equal to 6, and now it is in standard form. Alright, so let's write an equation for the line containing these 2 points, 4, -3, and 2, 1. And let's try to write it in each of the 3 forms, slope-intercept form, standard form, and point-slope form. Alright, we'll begin by doing it in slope-intercept form. Of course, in order to do that, I need the slope and I need the y-intercept. Let's first find the slope. Because we've been given 2 points, we can calculate the slope as the difference between the y-coordinates. So I'll do the second y-coordinate minus the first y-coordinate, and the second x-coordinate minus the first x-coordinate. This gives us 4 over -2, and so we have a slope of -2. So if you think about your form y equals mx plus b, we now know what the slope is. It's -2. And I'm trying to find out what the b is. One way of doing this is I can substitute in one of my points in for the x and the y here, and then solve for b. So I'm going to take my second point, 2, 1, and I'll substitute in my x value of 2, and I'll substitute in my y value of 1, and now I can solve for b. So 1 is equal to -4 plus b, and if I bring the -4 to the left, it becomes a +4. So this shows us that b is equal to 5, and therefore our slope-intercept form, y equals mx plus b, my m was -2, and I figured out that my b is 5. There's slope-intercept form. Let's do standard form. So I've already got my slope-intercept form. Perhaps I'll just start with that. Y equals negative 2x plus 5. And to get it into standard form, I want to have my x term and my y term on the left side of the equation. If I bring my negative 2x to the left, it becomes a positive 2x plus 1y is equal to 5. And now we've got standard form. Lastly, point-slope form. We require the slope, which we already have, of negative 2, and we require a point. And I've got a choice of points here, and so as I write into my form y minus y1 equals m times x minus x1, substitute in my slope, and I'll substitute in, I could substitute in the second point with a x-coordinate of 2 and a y-coordinate of 1. That would be correct. Or, if I wanted, I could use a different point on the line, such as the first one. So y minus the y-coordinate of the other point, y minus negative 3, becomes y plus 3. And I'll subtract the x-coordinate of that first point, and either of these would be point-slope forms. So what you'll notice is that there is only one possible answer for slope-intercept form. There is only one possible answer for standard form, but there's an infinite number of answers for point-slope form because, of course, there's an infinite number of points that we could use as that known point. In this case, I know only these two, but I could have used standard form or slope-intercept form to find a different point that I could have substituted in as my known point. Alright, we can test whether any particular point is on a line or not by substituting its coordinates into the equation of the line, so we can establish whether the point satisfies this linear relationship or not. So let's see whether the point negative 1 comma negative 2, is it on this standard form line? So let's substitute in the x-coordinate, and we'll substitute in the y-coordinate, and let's see if this is a true equation. So I've got negative 2 minus 10. Is this equal to negative 1? Is negative 12 equal to negative 1? No, of course not. And therefore we can establish that negative 1, negative 2 does not follow this linear relationship. It doesn't work, and hence it is not on the line. Let's check the other point. I'll substitute in the x value, I'll substitute in the y value, and let's see if that's equal to negative 1. Negative 6 plus 5, is that equal to negative 1? Is negative 1 equal to negative 1? Yes! And therefore we can conclude that the second point, negative 3 comma 1, is on the line, and is one of the points that satisfies that linear relationship. The slope of a horizontal line, if it's a horizontal line, then there is no rise at all. Imagine a horizontal line. There's no rise. So the amount of rise is 0 over whatever the run is. You know, it can be any change in x, but that's going to give you a slope of 0. And this would mean then, if you imagined your slope-intercept form of y equals mx plus b, but now remember that your slope, m, is 0, then we end up with simply y is equal to b as our form. So you'll notice that y is equal to a constant value. Let's just think about what's going on. We said here, a good interpretation of the equation of a horizontal line is that the y-coordinate is fixed, while the x-coordinate can be anything. So if we're looking at, say, a set of axes here, and this is our line along here, you'll notice that what's true, even though the x value changes, the y-coordinate is fixed every time at a particular value. That happens to be the y-intercept, b. And that's why we've got the form y equals b. The y-coordinate is fixed. Meanwhile, the slope of a vertical line is, well, imagine that this time with a vertical line, our rise is, well, whatever it is, delta y. But the run, as we move forward, there's been no horizontal displacement, so delta x is equal to 0. We're not allowed to divide by 0. That creates an undefined value. And because the slope is undefined, this means that it cannot be written in slope-intercept form or in point-slope form, because both of those forms require the m. But if you wrote it in standard form, just like previously with the horizontal line, we were fixing the y-coordinate. Now we're fixing the x-coordinate. So the x-coordinate for every point along the vertical line is fixed at a particular distance away from the y-axis, but the y can be anything. So our form, we can write it as x is equal to a, where x is always a constant. A good interpretation I've written is that the x-coordinate is fixed, while the y-coordinate can be anything. Alright, here's an example. Let's find the equations of the horizontal and vertical lines that pass through the point 4, -7. I'll draw a quick sketch of what's happening here. And so if you imagine your point 4, -7 right here. If we drew a horizontal line through that point, then we know that the slope is 0, and we know that the form of this line is y is equal to b. And because it has to go through this particular point where the y-coordinate we know is -7, and it's horizontal, we must be -7 units down for every point along the line. And so our equation for the horizontal line is just y equals -7. Similarly, if we drew a vertical line through this point, the x-coordinate is going to be fixed at 4 units to the right of the line, because that's where our known point is located, and so our vertical line is simply x equals 4. Parallel lines have slopes that are equal, while perpendicular lines have slopes that are negative reciprocals of one another. And by a negative reciprocal, I'm saying that if you knew that the slope of one line was 2/3, well then the slope of the perpendicular line would be the negative of the reciprocal, -3/2. One thing that you'll notice about these two slopes is that if I multiplied them together, the 2's will cancel, the 3's will cancel, and I'll be left with -1. And so the slopes always multiply in perpendicular lines to give a product of -1. So exercise, or example D, we need to write an equation in slope-intercept form for a line that has an x-intercept of 5. What's true at an x-intercept? Well, that must mean that y is equal to 0 on the x-axis, and so we've got a point here of -5, 0. That's just been given to you in slight code language. X-intercept and -5, that means that we got the point -5, 0. And if it's parallel to another line that's got this equation, well then it must have the same slope. So let's start with that other equation and figure out its slope. So that means that I should put it into slope-intercept form, which means I'm isolating my y value. So let's get the y alone and divide everything through by 3. And I can see that my slope of this line is equal to -4/3. And our line, which is parallel, must also have a slope of -4/3. I'm supposed to write slope-intercept form, so let's write that out, and I know now that my slope is -4/3. What I don't yet know is my b value, but I can substitute in my known point of -5, 0 for the x and the y in the equation to enable me to solve for b. So 0 is equal to -20/3 plus b, and that means that b is equal to +20/3. And so our final slope-intercept form would be y is equal to -4/3x plus 20/3.